Hey,
Hey.
Hey.
how's it going? How's it going?
Great.
Nice. Let me just move some things around.
Hi everyone. You can hear me, see me, yeah.
Yeah.
Hey,
Thanks
Vati.
for joining. You and Dave. So, more people are joining. Put the link to the document. I will keep the agenda. So I don't know if you are aware, but I think in Europe today is public holiday, so the participation to the meeting will probably be lower than usual, but we already have some good number of people joining on their way. Let me send a message to Slack as well, and we can give a minute or more people join.
Which holiday is it?
Ascension Day, or I don't know if all EU countries observe this. In Sweden, it's public holiday. I know maybe in Germany as well, but yeah, like I missed this holiday, so that's why I kind of thought of today as the day to have Cartographer present. But the meetings and the presentation will be recorded, so anyone who misses the meeting today can watch it afterwards.
Cool.
Let me share my screen. I don't know. I just moved to a new computer. I don't know if it will work. Let me try. Okay. Okay. So Zoom wants to quit, but I am not doing that. So what I will do, I will just walk through the agenda, which I passed the link to chat as well, instead of closing my Zoom client and opening it. And then we have a very light agenda, and we can spend most of the time for the presentation, demo, and discussion on Cartographer. And then if anyone wants to bring up an additional topic, we can do that as the time allows. So the first thing on the agenda is action item review. We don't have any action item from previous meeting. And the second topic is about the open PRs we have. The first PR is about the proof of concept we have been discussing for last couple of weeks. And that work started on HackMD, but because of some limitations with HackMD, like not getting notifications when people comment on the document, we discussed we should perhaps move the document to GitHub, and a pull request is created based on the document we have on HackMD. And this pull request is now open for comments. And Terry, you might not have got a notification for this either, so I will comment under the pull request so you see which one I am talking about. And also, I put the link to pull request on the chat as well. That's PR number 12 in our software supply chain SIG repository. And the second PR is about the contribution to SIG interoperability stages document. And that PR has been open for a couple of weeks, and there hasn't been any major concerns about the PR, except Anne-Marie wanted us to include some steps about the stages we documented there. But that was on purpose because I want to get feedback around stages first, and if people agree on the stages as a starting point, then we can start going into details of all these stages and look for existing steps, pipeline steps, and create new ones if we can't find a step we can reuse. So again, these are just on these two repositories open for feedback. And if any of you is interested to, take part in the proof of concept or contribute to stages vocabulary, please go ahead and comment directly on the PRs. So that was the only other topic we had before we move to Cartographer presentation. Anyone wants to say anything about these PRs? I know, Terry, you had some concerns about proof of concept being oriented around open source software. And I responded to your comment on HackMD, saying that we don't, we can perhaps start with open source software to bring the basics in place for the proof of concept, and then look for opportunities for thinking about more enterprise or commercial aspects. That was I think, one of the outstanding comments. So we can move that conversation from HackMD to pull request and continue the conversation there to see if we can move forward with it. So anyone in these PRs? Okay, then Steve, Zero, stage is yours. Please feel free to start sharing. I'm not sharing already, so and then yeah.
Awesome. All right. So we have a little bit of a presentation and then a demo and then a little bit more presentation, but hopefully it won't take too long here. So give me 1 second to share my screen. All right, can everybody see this? All good? Awesome. All right, so I'm going to talk a little bit about Cartographer, which is a kind of VMware open source project. There's some kind of software supply chain stuff in here, but it's focused on general presentation. What is the project? How does it solve problems in this space? Feel free to stop me at any point and ask questions. Not a huge group. We can it can be kind of informal. So I'll start with that. There are a ton of Kubernetes native CI/CD tools now, right? So the space is kind of getting crowded. There's Flux and Argo and Tecton. Argo also has Argo workflows, which kind of looks like Tecton in some ways, right? Shipwright. At VMware, we have an open source project called KPack that does Cloud Native Build Packs project. There's Carvel, that kind of handles deployment. There are a lot of interesting tools in the space that solve CI/CD problems, and all these tools present a Kubernetes native interface. They use CRDs as their kind of level triggered interactions as their way to provide a user interface into what they do. And so at VMware, we looked at kind of that ecosystem and said, can we build an application platform that is really an extension to Kubernetes, using these tools, right, and provide users with a kind of secure software supply chain that meets, and I'll kind of go into this a little bit, operator and developer needs at the same time, right? And so, the way we're thinking about this abstractly is, well, can we take these tools like, say Flux to, monitor a Git repository for changes and hook that up to Tecton to run some unit tests. And then, once those tests pass, give the source code to, a KPack's image resource to kind of build an image and keep that image up to date with security vulnerabilities, and then generate some Kubernetes configuration, and deploy an application using Carvel, and maybe use Tecton to run smoke tests against it or something like that. We were thinking about how can we take these tools in the space and create a Kubernetes native application platform using those tools, right? A big aspect of this is, everybody has different opinions, different problems they're trying to solve, right? How can we keep those tools swappable? So when you want to use, Argo instead of Carvel, it's an easy thing to do, right? And at the same time, especially relevant, I think here, how can we allow you to integrate different tools in the ecosystem into this, kind of set of services? So you can sign images with cosign as part of SIG store, so you can maybe scan images using Gripe, or do static analysis using other tools, right? And I think kind of a big principle here is that we wanted to create a self-serve developer-focused application platform using those tools, but that also, kind of lets an operator define a path to production through them, right? That kind of balances concerns for those two personas. And again, abstractly, the way we thought about this is, okay, so you could have developers, each with a namespace. Maybe some developers are sharing a namespace for their application they're developing. How can we take the kind of operational configuration, say these are the services that people are supposed to use in order to build applications, and allow an operator to say, here's a path through those services that can then scale out to namespaces, so that when an operator wants to change a service, change the configuration for a service, right, do whatever, change their platform, right, that can apply to developer namespaces, and they get instead of having developers with a lot of sprawl based on templating or examples, right, in an organization, create infrastructure that is kind of maintainable and configurable on the operator side. And another thing we were really influenced by, I think Captain had some good blog posts on this idea, like orchestration versus having kind of CI/CD microservices or choreography, right, is a word some folks have used. That instead of focusing on how can we build individual imperative tools that get executed, to form a pipeline, how can we treat the different tools like microservices, and think about instead of this is the image building step, right, this is the image building service. And maybe in the case of KPAC, when a new dependency is available that patches a CVE, instead of having to run the pipeline from the beginning, you just rebuild the image for that one component, and that kind of in a declarative and level triggered way gives you a new copy of your deployment in the end. And so the solution we came up to, or the solution we came up with in the space is called Cartographer. And I'll kind of go through the different pieces of Cartographer and how it kind of implements that vision I was talking about. So when we say operator defined path to production, what we mean there is our implementation for that we came up with in the Cartographer project is what we call a supply chain, the resources cluster supply chain. And this is basically just a list of references to templates for existing CR, first CRs that could be stamped out in the cluster, right? In this list, the inputs and outputs between those CRs are specified in a high level way. So you might have a CR that's providing, will get stamped out that's providing source, and then a CR that gets stamped out that's running unit tests that references that source providing CR, and a CR that's building images that references the source code coming out of the unit tester, etc. Right? The kind of key thing here is this isn't a linear pipeline. It's not an execution of these things in a row. It's really persistent, mutable CRs that are created, and the way data is passed between them from the status of one to the spec, to spec of another. And so if you look at one of these templates, you see like this is our template for a KPAC image, which is a resource that continually rebuilds images when new sources available or new dependencies become available through the build pack model, with kind of an operator control plane there. And you can see in the template, there's an input like the source URL coming from previous stage, and there's an output, where in the status of the resource to look when that status gets generated for a new image to get generated. And so Cartographer's job is to stamp out that KPAC image and then keep it up to date over time by reapplying this configuration as the inputs change. And so to kind of visualize this a little bit, if it wasn't clear what I was talking about there, if you imagine you have a cluster supply chain resource, applied to your cluster, it's a list of references to templates, and it's going to pass kind of typed information, commits of source code or images between those templates in a way where if an operator were to update one of those templates in the cluster supply chain, it would automatically change the resources that get stamped out in the developer namespaces, which I'll go into in a second. For some tools like Tecton, which work, like Tecton is a tool where you define a pipeline or a piece of functionality it has is you define a pipeline, and then whenever you want to run the pipeline, you create a pipeline run resource. And so in order to kind of transform that from these sort of immutable pipeline runs into something that's continually running a pipeline when new commits are available, we made a little adapter called runner that just, it's a resource that has a pipeline runs as child resources and garbage collects. If you have more than 10 of them, it throws the old ones away. So it's a little, kind of immutable to mutable state translator. And that was necessary for things like Tecton and Argo workflows if you want to integrate that. And so, really a big part of the goal here is to create a self-serve developer-focused application platform, right? And so the input to this is a really simple resource, right? If you're a developer, all you need is, create one resource in the cluster that says, here's where my source code lives, look at this branch for updates, right? Maybe you want to specify some environment variables. You're building a Go app and you want to turn SIG off or something like that, right? But we wanted a really simple developer configuration, with maybe progressive complexity, right? As you need more, you need to break more glass, you can break more glass, but the entry point is very simple. So when a developer creates one of those workloads in a namespace, a cluster supply chain, if it's available in the cluster, finds one of those workloads and automatically begins to reconcile resources of other operators, right? Like a FluxGet repository or a KPack image or a Carvel app as child resources underneath that workload. When I say reconcile, what it's really doing is it's kind of emulating the actions a user might take. It's looking for changes in the status and moving them to the spec of resources further down the chain, using by restamping those resources out using the kind of templates I showed earlier. And we also, this isn't just, this is very configurable in some ways too. So as a developer, you could bring a Tecton pipeline yourself that runs your unit tests and then pass the name of that pipeline through so that the pipeline runs at the unit test phase, execute your custom pipeline for your individual workload, not whatever some operator decided should run for an entire platform, right? Because usually, unit tests are something that's application specific. And with that kind of high level overview, I'm going to turn it over to Ciro for a bit to kind of give a demo of what we put together.
Thanks. Could I share the screen, Stephen, please? Awesome. So differently from Stephen, I'll take the mad scientist approach, everything on the terminal. I tend to go a little fast, but feel free to interrupt me at any time. I'll try to repeat myself multiple times too, so everybody can get on the same level. So I'll just try going back to the initial idea of we're trying to allow people to create these platforms and then arrive at where we're at right now. Because then further in the presentation, Stephen will be talking about some thoughts for the future. But I'll try to take a step back, get to today, and then Stephen can move on with the thing for the future. So I'm gonna open a little file here so we can start thinking about if we were to create a platform, what could we do? If we're just to describe it at a high level, what we're trying to offer to our customers, putting the app operator hat, the platform operator hat, my customers being the development teams in my company, my org, what could I end up coming up with? So from that perspective, our customers, well, what they're here to do, they're here to code their app. They're in this company to provide value, and they know very, very well, let's say, about Go, about Java, who knows, right? They know about their application. They want to just provide this description of where their app is and have it going through the system so they can, focus on their main job. So I'm, as a developer, just telling the system where my code is. And what that is essentially what Stephen was showing at the end, which was that workload definition, right? So, okay, in the system, in this platform we're building, the developer has a way of providing some input to point at the source code location. Now, what should this platform do? So taking the examples that Stephen was talking about of, you push a code to repo, run some tests, then you build an image and then deploy. We could express that in this scratch space that we're just thinking here. So, that pushes code to the repository. Next thing that you would expect to happen as a dev, well, tests are executed, then container image gets built, and then somehow the application gets deployed. And then when we look at the Kubernetes landscape, you could CNCF landscape or any one of those, you start seeing that, yeah, there are some pretty good tools out there that do the job that we're trying to accomplish here, right? Like Stephen was showing, there's Flux Git repository for, let's say, keeping track of those commits that lands in the repository. For running the tests, well, Tecton's great, right? Provides all these primitives like Tecton pipeline, tasks, so on and so forth. And for building container image, well, then we also have a lot of projects here, like Shipwright. We have Kpack. We could do like Tecton plus Canico. Canico build image. Like there are tons, right? But ultimately, the line of thought is the same. You're in this Kubernetes landscape. There are all sorts of projects out there that do their job really, really well. I'd really like to just be able to pick and choose some of them to build my platform. And then final portion here, application getting deployed, that could be either like Stephen was saying, like Argo, could be cap controller, so on and so forth. It could be anything that deploys some Kubernetes configuration into the cluster. So cool. We found that there are all these projects out there, but there is not really a good way of linking them in a way that I can express that. For instance, I could, let's say, take the commits that get found, like the Git repository resource, pass it to the pipeline so that it can then like run the tests. That once the tests, like say, passed for commit 1, that then we build a container image out of that. So build the image that then we can deploy. But we can intuitively think about this as, well, if for the Git repository in their spec, I'm providing, let's say, the location of the repository, and maybe I'm saying, hey, this is the branch. And I know that at the status of the Git repository, I can find the revision that it found. Well, that's essentially this thing I'm trying to pass to the next resource, right? So what if I took that from the status right here and it plugged into the status of these pipeline runs or task runs that I'm creating to run tests against that particular revision? And if I think of running tests against a particular commit, and then thinking of this resource as something that's like gating revisions from moving across the supply chain, because maybe you want to not promote source code from a commit that fails the tests, then you can think of something that, like, in its spec, you put a revision there. In its status, it says, hey, this is the revision that successfully did what it was supposed to do. Then, wow, that's something that I could pass forward again. So similar to Git repository, where maybe in your spec, you're saying, hey, this is my URL in the branch, give me a revision. Giving a revision, it only promotes forward revisions that have successfully passed the tests. If I think of this resource here, I'll put just Kpack so we have more space. And in the Kpack spec, I say, hey, build a container image for this revision. Well, what would be the status? Well, if you look at Kpack image resource, or even if you look at the, let's say, the Tecton Canico task from the catalog, you see that it always reports something that's like a latest image, like the image that got built and pushed to an image registry. And well, that could be the thing that we pass to the next resource here. So for instance, it could be that I'm deploying a Knative service, or maybe after V1 deployments, like anything that deploys Kubernetes objects. Well, if this thing takes configuration that has that image that got built right here, then we can intuitively start getting the sense of, oh, what I'm trying to do here is take something from the spec, that service reconciles whatever you're trying to do at that stage of your supply chain, and take that output, then pass forward to the next. resource in that chain. Take the output, pass to the next. Take that output, pass to the next, so on and so forth. So if you think about Cartographer as this controller that's taking these objects that get stamped out and applied to the cluster, looking at their status, then updating other objects in that chain, you can see that what's missing here is providing this like linking between these different resources, right? And again, that's where Cartographer comes in place. This is where that object that Stephen was showing comes in place, which is the cluster supply chain. In the cluster supply chain, what you're doing is you're defining essentially a graph that's saying that, for instance, that the tests, they need to take a revision from something that provides revisions. For, let's say, the image builder resource, what you're declaring is like, oh, I know how to stamp out something that builds container images, but I need a revision. And so you link this, this image builder resource to this source tester. If you were to, let's say, my company doesn't do tests for some reason, what you do, take that resource out of your supply chain, and wow, this thing takes a revision, right? This thing gives you a revision, so you can like link them together. And so what we're landing on here is a very like flexible way for you to build what your software supply chain can look like, where you can both replace, let's say, the opinions of what a software supply chain looks like for, let's say, a part of the org, and then another part of the org, it could be that, yeah, they do TDD, like they are very into tests. And then maybe there you have a supply chain that has like extra resources to do different things that other supply chains don't. But ultimately, going back to the beginning, as a platform operator, you're able to create essentially this kind of dependency graph between Kubernetes resources. And so by doing all of this in a like level trigger manner, we're able to also achieve what Stephen was mentioning, which is this notion of if there is anything that happens, let's say KPAC here in the middle, the thing that's building container images. Well, to build a container image, you need a, let's say, a builder image. If I have, let's say, a Golang application, well, I need Go, like the compiler, to build it in the first place. But it could be that for this revision, let's say commit 1, I had like the version of Go that was used to build this particular revision had a CVE, let's say Go 1.18, KPAC, because it keeps track of those builder images. KPAC knows, oh, there's a Go 1.18.1 that addresses the CVE. It produces a new image, let's say produced image 2. Again, that test has already been executed for that revision. No need to run it again. So because the status here changed, and this resource depends on the image produced by the image builder, then we get this automatic like redeployment in this case, because now there's a difference here, and then Cartographer goes to Kubernetes and applies that change. So stepping back, a little bit of ASCII art. So this is from our examples in the Cartographer repository. Being like super bare bones here, what Cartographer is doing is letting you specify dependency between Kubernetes resources, and then you specify how to create each one of those resources and how to grab certain pieces of data from them to then promote to whoever needs it, as described by your supply chain. So just one more time before we dig into YAML. As like a platform operator, I'm defining how the software supply chain looks like, right? This is like how each resource links to each other. I'm defining which Kubernetes objects end up being created in that cluster, in that developer namespace for that particular service. Like in this case, figuring out commits that are pushed into an image repository. And with both those two concepts together in a supply chain, all it takes for you as a developer is to create a workload. So submit the workload that's describing like where my code is. And then if I push one workload, it's gonna go ahead and create the whole chain. So create another workload, same thing for that other workload. But with the details passed in the workload, gonna be like populated in these objects that got created. So enough said, let's dig into the demo. So the demo I have literally making use of these Kubernetes resources, except that I'm not using Argo here. I'm actually just using Controller. And what the demo is going to show is once we create this workload, we're going to see this object tree being created, and then we can follow along with our application going from like source code to something deployed. Cool. So onto the demo. So as I mentioned, going to start going very into the YAML here. So I have just a little bit of namespace set up here, like service account, providing the roles for our controller to be able to create those objects in the first place. Like someone needs the permissions to create a Git repository. Someone needs the permissions to create pipelines, tasks, Kpack images, so on and so forth. So I'm saying, hey, in this namespace, whoever uses the service account gets those permissions essentially. And then as a developer, what I'm gonna remove this one. So as a developer, let's say I'm creating this application called app, and I'm telling it, hey, the source code for it you can find in this URL and this branch. Please keep building the application for me and deploying to this cluster. Oh, and sorry, one detail I forgot. Here in this example, we're deploying to the same cluster, but you don't have to do it that way. So like internally, for instance, the supply chains we have, they don't really deploy directly, but instead like pushing the configuration to a Git repository, then other components can do that job of deploying once they get merged in. But anyway, so got the workload describing some traits about my app, as well as like, hey, this is where my code lives. I'm gonna go ahead, I'm gonna create this workload. Cool, workload created. See, workload got created. It's not ready yet. That's because there are some things going on. Those things going on are essentially what I said before. So the controller, knowing that it has to create 4 resources, the first being one is going to keep track of commits pushed to a Git repository. The next one, something that knows how to run tests. Third one, something that knows how to build image. Fourth one, at this point, the app got created because like we finished building the image. This got created. If I go ahead, copy this, create, let's say, a second workload, then we're able to showcase essentially what Stephen was showing with the, oh, if I were to now introduce like a different team to this platform, what would that team do? Well, in this case, the team that's building the UI of the larger application called app, they create another workload, point at their repository, and submit it to Kubernetes, right? Submit it to Kubernetes. I'm gonna clean this. Okay, look at the tree again, the object hierarchy for UI. Same thing. It's going to try, so the controller is going to then like relentlessly make that a graph that describes the dependency between those resources exist, right? So it's gonna create the Git repository, it's gonna create the runnable for running the test, creates the image. At this point, the image is probably built. Okay, not yet, still building. Build logs UI build. So it's still building. Okay, just finished. As it just finished, app got created. So cool, we have like these 2 trees, right? These 2 like object hierarchy trees. We have one for the app, another for the UI. As you can see, the objects are different. So it's not like we are creating like one Git repository that keeps track of every single Git repository out there. No. So for each workload, we create that same path to production that the operators described via the definition of the supply chain. So at the end, everybody in the org that has a workload that's saying, hey, I'm a web application. Here's my source code. They will all go through the same path to production as described by that operator team. Now, digging a little bit into the YAML, I'll start with supply chain, which is where you're describing that dependency graph between the resources. So if we look at how that looks like, you'll see a little bit of templating here. This is for making testing this easier and providing defaults into some of these values. But essentially here we have that dependency graph where we're saying, hey, the source provider resource, you create an object as described by this template right here. And that's a cluster source template. It's something that's going to provide you with source information. If we look at that template, how that looks like, which in the templates I have here, if I look at Git repository, and here we have the template. Now I can see here I'm using RTT instead of the template view that Stephen showed in the examples. You can either use YTT for templating or the JSON path-based templating we have. But regardless, going back, cluster supply chain, describing that graph of the dependency between those resources. And then in the template that we're pointing at for this resource, we're saying, hey, this is how I create a Git repository. And then as you can see, we're taking some data from the workload. That is, we're taking the Git URL and the Git ref. And then if we look at the Git repository that got created, Git repositories, and look, let's at the UI one, we see that it exactly as we specified, right? The URL from the workload, the ref from the workload is all here. So like I was saying before, in the package Git repository, we're saying, hey, keep track of commits made to this repository. In the status, we have what they discovered. Like, hey, this is the latest revision. So what happened right after? Based on this dependency graph that we established here, well, because this resource, the source tester, is explicitly saying, I need source from this guy right here. Then what we're doing is we're taking the URL that's found at this location, the revision that's found at this location, status.artifact.url, status.artifact.revision, and then that will be made available for this component, for this resource, and so on and so forth. So if the test succeeds, and in whatever URL and revision path we specified for the source tester, then we're going to make it available for the next resource, the image builder, so on and so forth. And what's really cool about this is that behind the scenes, all the cartographer is doing is relentlessly looking at this graph and then evaluating for each resource whether it has something new to present to Kubernetes or not. If it has something new, then it's going to patch the object and let it do its thing. Once, let's say, the KPack image finished, for instance, right here, using KPack, once it's finished, then its status is going to get an update. And what's going to happen? Oh, sorry, that's kind of. And so once like KPack finishes building the image, its status, the latest image gets updated, and then the deployer is going to take it because it takes an image, which the image builder provides. So again, I'll be reiterating this. Supply chain, describing this graph that tells cartographer the dependencies between these resources. Behind the scenes, cartographers relentlessly trying to make the current state of the world look like the desired state, which is having this graph always up to date in Kubernetes. And that is pretty much it. The only last thing I had, I know we don't have a lot of time, was showing like how I could swap this. And I was gonna do like, hey, swap this with Canico, and there we go, because I have a template. Sorry, I forgot to show a template called Canico, and then that would be like, hey, this is how I could make this swappable without you even having to think about the dependency graph. Because at the end of the day, this is an image template. This takes an image. So, well, Canico knows how to build images. It can be an image with Canico. Actually, let's do that. I'll delete it. Sorry, I'll cluster apply. See, so updating supply chain instead of pointing at KPAC for the template, pointing at Canico. I'm gonna let me delete all the workloads just so we can make it faster. Let me apply this one. I'll apply this one. Give control, apply to chef. Cool. So yeah, same thing's going on. It is going to start creating those objects, making the graph materialize in Kubernetes. If you do a tree, okay, I created the app one. So we can see, get repository got created, test got ran, and now instead of seeing the KPAC image, what we're seeing here now is this runnable, because we're using Tecton under the hood now with Canico to build that container image. If do, I forgot task run logs. We can see, okay, we can see the test worked well. And we can see the build is taking place. And that's showing, yeah, like how you can swap those templates. There are a couple other features, I'll not get into it, but we could even make it so that depending on, I don't know, a parameter that you pass to your workload, if your supply chain supports providing like optional templates, we could say, let's say name, like Docker file, and if you pass like the location of the Docker file, it could use Canico, or if you don't, you could then use KPAC. So even though we have that dependency graph that the supply chain pretty much is, you can also in a declarative way declare that like, oh, you use this template if in the workload you have like these properties set or these other properties set. I'll not get into that right now, but if you want to know more about it, go in cartographer.sh. That's our website. There's the documentation there, there are examples. And yeah, that's it.
All right, so I have a couple more, just I think 3 more slides, and I promise we'll we'll stop for questions here. So the final, give me 1 second. Can everybody see that again? All good. Okay. So the final thing we wanted to talk about is how are we thinking about the future of the project, right? Where are we going from thinking about connecting together CI/CD tools in the space? What have we learned since we put that together and have a couple of users now? And so I think a lot of feedback we've gotten is that our CRDs are we have a lot of CRDs and they're very domain specific, and folks have a lot of problems that could be solved that are a little bit outside of the domain of creating an application platform that takes source code, turns it to an image, creates Kubernetes configuration, promotes the configuration forward. That there are use cases for kind of operating other operators that go beyond that, and maybe we could make things more generic in some places to support that. And so there's an RFC out right now that kind of flattens those resources into a more generic resource that's just called cluster blueprint, or we'll have a blueprint namespace scoped version that's more nestable. So you can use instead of a template, you can reference another supply chain that'll kind of get inserted into the graph, and that lets you define the types yourself and the schema for each type, so that instead of a baked in image type, there's a cluster blueprint type you register that can be called image, and that's what you promote forward. So that's what we're looking at doing for kind of subsequent versions of this. We've seen some really interesting use cases in taking, like a bunch of different service related resources and kind of coalescing them into one resource that, maybe presents information on, a unified like piece of information on what that service looks like that other things could consume is like one use case that we've seen that's come up. And so that's kind of how we're thinking about the project moving forward. It's kind of like an operator that lets you declaratively define interactions between other operators using YAML and Kubernetes without creating your own operator yourself to do it. And now finally, hopefully we left enough time for all the questions you might have about the project.
Maybe I can start. Now the thing you mentioned a few times, like how to make use of different CI/CD tools, is a topic we have been working as well. Like essentially, people need something that enables them to use different tools. Like it's not limited to CI/CD tools either. Like it could be build tool, it could be artifact repositories, and so on. And that actually results in some more concrete work, which was recently announced, the CD events project. And I think, David, I asked you on Slack as well, because when I look at Cartographer website, I see lots of great things, like the challenges organizations or people face and how they could overcome those challenges. And the pattern I noticed on the website is like, you also talk about events on the website, but I couldn't really find detailed information about what events we are referring to and how those things could be generalized. Like, are they like Kubernetes specific events or some other event framework you have around Cartographer? Because kind of that is very common thing we are talking as well in making tools work with each other in a same manner.
Yeah, that makes sense. So the question is, essentially, how do events play into this, right? Like, what's the story around that? So when we talk about events with Cartographer, we're talking about Kubernetes API server events, right? The way Cartographer acts as we say as a choreographer instead of an orchestrator is that it's listening to status sub-resources on these for status changes, which are events, and then taking information from the updated status and then moving that to the spec of other resources. And in that sense, it's event driven, but it's not like using edge triggered events like Captain would use, where the events could be missed, right? It's using events in a level triggered way where the system is always going to reconcile towards the current state. And so in some ways we think of that model as maybe a little more robust, or that it there are no events to miss. So you're going to get it in one iteration, or you're going to get it in the next, if that makes sense. But we don't currently support other events outside of events within the context of a single Kubernetes cluster, and we use external resources to do like cross-cluster orchestration type things, like writing to a Git repo with configuration that gets picked up by a resource in a different cluster. That doesn't mean we're not thinking about what that could look like in the future, right? And so you could imagine cloud events being used between clusters, or other kind of similar ideas to that. I think a challenge there has been that it's because we really like this level triggered model. It's a little difficult to kind of reliably do level triggered eventing across clusters, like replicate a level triggered resource in a different cluster. And so, but we've definitely kind of thought about different ways we could achieve that.
Yeah, I just wanted to add one thing to it. Another detail about all of this is that, as you saw, like, we're using Tecton under the hood. We're using the Flux Git repository. Like, you got to pick and put those tools in the places you want. And so, if, for instance, you're using Tecton and Tecton emits CD events, compliant events somehow, and you're able to grab them, but like, you can still make use of that. Cartographer, the controller itself, at the moment doesn't emit any event. We have an RFC, we're like starting to implement it. But like Stephen was saying, those would be Kubernetes like core events. We haven't yet like dig into much deeper than that, but I could imagine that if you have something that collects those Kubernetes core events, you could then expose them in other ways. But ultimately, because we're using the tools that are there in the landscape, if they start like implementing those specifications, then awesome, right? Like you get to leverage them just by the fact of them using them. Sorry, implementing them.
The other reason why I'm asking this, there was a CD events con, I think it was last week. No, I don't, yeah, I think it was last week. And there was a really good talk there from Eric Sternerson, who actually works with Volvo cars. And they develop embedded software and they don't have Kubernetes, you know. And like, if you don't have Kubernetes, then okay, you need something that could help you plug in different tools that may not be coming from Kubernetes ecosystem, for example. And that, like, they have their own CI/CD pipelines or whatever. They need something like what Cartographer aims to address with bringing different tools together. So yeah, in summary, what I am trying to say, yes, it's cool that you enable all these different tools to be used in a, you know, streamlined manner, or in a, you know, choreographed or whatever the word is. But yeah, there are organizations out there that are not in Kubernetes ecosystem because of their business, you know. So.
Yeah, I think one way we think about that is, you know, if you have CI/CD tools that aren't already Kubernetes native, right? Like you have a traditional Jenkins pipeline or something, that those tools can often be adapted. So like there's a common pattern we've already seen where you just use Tecton as kind of a general adapter for anything, right? Where your Tecton pipeline run, you know, there's the Tecton catalog has, you know, I think a Jenkins integration, right? And so you use a Tecton pipeline run that talks to Jenkins, runs a Jenkins task, and comes back into the pipeline. And so as long as you're willing to use Kubernetes as the kind of central piece, right? You're not necessarily limited to just Kubernetes native tools on top of that. And I think, you know, we see a lot of people moving to Kubernetes for infrastructure abstraction, so that it doesn't worry us too much, if that makes sense, that we have that dependency.
Okay, any other questions to either Stefan or Ciro?
Oh, sorry. Could you say it again?
No, I was just asking if there are any other questions to you. Yeah. And maybe I can say one more thing. I promised Mauricio Salatino, who is contributing to CD events project heavily, like since its inception, even before it became a project. And he was the one who actually created this proof of concept using Captain and Tecton. And I asked, like, because he is like part of the VMware organization, I don't know if you know him. And I was like asking similar questions to him if he is aware of any work happening in Cartographer. And he asked me to ask you, like, you should look at CD events. So I'm being a messenger now.
Sure.
Yeah, because he did lots of contributions to the project, and he will probably continue doing that.
Yeah. Follow on that, I just put in our chat the playlist for CD Events Con last week that took place co-located with KubeCon, and Mauricio spoke at that, and he has a really interesting talk about using events between, like, in a multi-cluster way. So, you know, it might be interesting for you, and certainly, yeah, he's a fun one to chat with.
Makes sense. I think there's definitely an opportunity to, like, because the events we're talking about are really within the context of a single Kubernetes cluster. You know, it's really just building on top of what Kubernetes provides, and there are definitely limits there, right? And so it was, you know, I don't know if in the end these tools are going to compete necessarily, or if it's like within a cluster you can use Cartographer for some things, for scaling out an application platform, and then between clusters, you know, you have these other, or for services that, you know, aren't Kubernetes native in some cases, you have these other ways of doing events. I could see a great story with those tools together. So definitely interested in seeing what's happening there too.
Nice.
Okay, we have 5 more minutes. We can have more questions.
Question, are you trying to say something? I saw you tried putting the video on. And
I was just going to say that that cross communication, like my first pass at how would we integrate with cloud native events would just be if there's some resource that you deploy on a cluster that's listening for events and then is responsible for reflecting those as a status in that level, Stephen was talking about, like, essentially an edge triggered to level triggered translator. That would be something that would, that adapter could just be created independently of Cartographer and then would allow for the integration of those two patterns.
Okay. Thanks, Ashima, for info. So I'm not seeing or hearing any other questions. So thanks, Steve and Ciro, for your presentation and then demo. And David, thanks for getting us in touch with Steve and Ciro. I think, like, when I look at the website and I browse through things, it looks very cool. So I think we will continue talking and see how we can collaborate between Cartographer and other projects or the 6 we have in CD Foundation, because, like, as you highlighted, there are some trends where people are following, and perhaps we should find how we can collaborate on better working on those type of things together, like cross-community collaboration, not just within CDF, but across the ecosystem, which could be under CNCF community and elsewhere. So with that, I want to thank everyone for joining today's meeting. And the next meeting is supposed to happen on June 6th. Oh, sorry, June 9th. But we have CDCon that week. I guess we may not have that meeting during that week. I will send a message to Slack channel to ask if anyone has a strong opinion to have the meeting or not. If not, we will cancel that meeting, and then that makes the meeting on 23rd of June our next meeting. So, but yeah, please check Slack to see what's happening, and if we decide to cancel the meeting, we will cancel it on CDF public calendar and send notification on this channel. So with that, thanks out again for joining today, and see you in a couple of weeks, if not before, during CDCon. So thank you very much. Have a nice day.
Thank you.